Hey everyone, in today's episode I'm going to talk about black holes. What are black holes? The categories of black holes and the anatomy of a black hole. So let's dive in. So what is a black hole? A black hole is a region of space-time where gravity is so strong that nothing, even light, can't escape. This region, where there is no escape for a particle, is known as the event horizon. Primordial black holes were formed right around the time after the Big Bang, whereas stellar black holes are formed after a massive star collapses at the end of their life cycle, which also includes our Sun. So a black hole consists of two parts, namely event horizon and singularity. The event horizon is the region where, when a particle reaches it, nothing can escape, and is mostly present on the surface of the black hole. And people would wonder where the surface of a black hole is. Okay, coming to this. Singularity is described as a point which is infinitely small and dense, hence the gravitational effect it has. So, there are four categories of black holes: primordial, stellar mass, intermediate mass, and supermassive. We'll be seeing them in detail now. A primordial black hole. These black holes have been theorized to have been formed after the first second of the Big Bang, or the birth of the universe. This theory states that pockets of hot material, which were dense enough to form black holes, had their masses ranging around 100,000 times lighter than a paperclip to 100,000 times more than our Sun. And as the universe expanded and cooled down, these conditions for forming black holes ended or stopped. This way of forming black holes is still only a theory, and it hasn't been proven yet, even though research is being conducted. According to this theory, lower mass black holes weighing less than a mountain would evaporate quicker than a larger black hole, meaning early smaller black holes could have existed but would have evaporated or dissipated completely, and larger primordial black holes could linger across the universe. Stellar mass black holes. When a star, more than 8 times the mass of our Sun, runs out of fuel, its core collapses, rebounds, and goes supernova. After going supernova, what's left behind is a neutron star, which is about 20 times the mass of our Sun. If it is more than that, this is known as the threshold or mass threshold or Chandrasekhar limit. If this limit is crossed, or if it is more than this limit, the electrons are no longer strong enough to prevent the star from collapsing, and this leads to another supernova event. These black holes could be around 100 times the mass of our Sun and gains mass through collision with stars or other smaller black holes. Intermediate black holes. Scientists are still puzzled by the size gap seen in the stellar and supermassive black holes. Hence, as all humans always expect an order of size, they came up with this category. They theorized that not only do stellar and supermassive black holes collide, as they had observed two supermassive black holes collide recently, forming another supermassive black hole. So if two stellar mass black holes collided, they would form an intermediate mass black hole, which is slightly bigger than stellar mass. And these black holes would have a mass of around 100 to 100,000 times Sun's mass, and scientists are yet to identify these black holes as the hunters on for these missing link black holes. Now come the big one, the big daddy as they say, supermassive black holes. These black holes are present in almost all large galaxies, even ours included, and these black holes have a mass from around 10,000s to a billion times of our Sun's mass. The black hole at our galaxy's center, which is the Milky Way galaxy, is called Sagittarius A star, and it has a mass of 4 million times of our Sun. which is relatively small compared to other galaxies. For example, a black hole at the center of a galaxy called Holmberg 15A holds at least 40 billion solar masses. Imagine that. Must be very massive, huh? Observations show that these types of black holes formed around 1 billion years after the Big Bang, indicating massive stars collapsing, giving them a head start. These black holes can also grow by consuming the smaller black holes and neutron stars, and can also merge with other equally sized black holes when galaxies collide, which will happen to us and Andromeda in a few billion years. Now we're going to see the anatomy of a black hole. Although black holes seem to be massive and have no definitive shape, they possess three main properties, namely spin, mass, and electrical charge. In the following minutes, we'll be seeing the common features of a black hole. The first part of a black hole we see is called corona. No, not that guy, not even this one. I'm not sure how many of you have seen Interstellar, the movie. That's how it'll be. This corona is a tenuous, turbulent cloud of light, which is at least 1 billion degrees hot, extending above and below the disk. If by chance you make it near a black hole, that's what you'll notice first. Then comes the accretion disk. This is a hot disk of gas orbiting the black hole and is the main source of light to visualize the black hole or to see the black hole. This is caused by gravitational lensing, which is the light from behind the black hole bent like a hump on top of the black hole and at the bottom. Some isolated black holes don't have this accretion disk, as they have consumed their surrounding matter and, are just dark and lonely. Poor guy. So, the next one is particle jets. These are a stream of matter moving away from black holes at nearly the speed of light. So that's the particle jet. Need I explain more about that? If you do let me know down in the comments. I'll help you with that. The next anatomical part is Doppler beaming. This is an effect which causes the accretion disk to be bright when it's spinning in the direction towards the viewer and dim when it's spinning away from the viewer. You can see it here in this video, here and here. The next anatomical part is the photon sphere. These are thin rings of light appearing at the edge of the event horizon shadow. You see that dark circle above that? You can see a boundary? That guy. The event horizon shadow is the next one. It is a dark zone which is roughly twice as big as the black hole's event horizon. And the event horizon is the region where the velocity needed to escape a black hole equals the speed of light. Once inside or on the event horizon, there's no point of return at all. And after this comes singularity. This is the theoretical point at the very center of a black hole where matter is crushed to infinite density. And this is where that process called spaghettification happens, where you are compressed horizontally and stretched out vertically. Hence the name spaghettification, because you look like a spaghetti. The black hole is a very interesting celestial body which gets interesting with each perspective of research. We'll be seeing about these guys in the upcoming parts, and if you have any suggestions for the video, you can always let me know down in the comments. Don't forget to like this video, comment your thoughts, and subscribe to the channel for more informative videos, and stay tuned. I'll be seeing you soon, and ciao. Let's leave this black hole before its success.